Okay, so today we're starting chapter 4. Section 4.1 is samples and surveys. Get my screen ready. Here we go. All right, so first thing we want to talk about is what the difference between a population and a sample is. Okay, a population is everyone, okay, and we call a population a parameter. So it's a number about a population. It's called a parameter. Push down harder, sorry. And if it's a sample, we call those numbers a statistic. And that is important to know and understand. I'm not sure why my pen's acting up today. So if a number comes from a sample, it's a statistic. If the number comes from a population, it's a parameter. So what is the difference? A sample is a little subset of the population. So a sample of Urbana High School would be randomly selected 50 students from Urbana High, where the whole population would be UHS. So that's the difference between a sample and a population. And if it's any number talking about a population, we call it a parameter. Any number talking about a sample, we call it a statistic. All right, so how do we choose these samples? So the first thing is to be very specific, and you want to define your population you want to describe, and we will practice that in class. Then you want to say exactly what you want to measure. You want to measure a mean, you want to measure a median, a percent. All right, so then the sample survey is a study that uses an organized plan to choose a sample. So your sample survey is how you're getting these people. All right, and then decide how to choose the sample from the population. So are you going to do a random sample? Are you going to do a systematic, stratified sample? And we're going to talk about those things as we go on. Okay, there are a lot of ways to sample badly. One of the first ways to sample badly is talking about a convenient sample. And a convenient sample is convenient to whoever is doing the sampling. So let's say you wanted to ask students about parking at Urbana High. And so you're normally, you're assigned a place during a regular school year, you're assigned a number, and you want to know if that number system is good, where you're assigned a specific space, or if you want to just be assigned a lot, like the gym lot or the auditorium lot. So a convenient sample would be you standing outside in like the auditorium lot one morning, and as students roll up into school into the lot, you ask them if they like the current parking rules. That's convenient to you. You're not using random. You're not using any kind of random sampling at all. That is convenient sample to you. And there's a lot of what we call bias in it. So bias is a big word in AP. And bias is any systematic error that will favor a certain outcome. Okay, that will favor a certain outcome. Here's an example with bias in the parking lot situation. If you go to the auditorium parking lot and you ask people there if they're happy with the situation, maybe those people were all mad because they really wanted over in the gym lot and in the cove, and they didn't get a cove spot. Let's say that the next morning you went and did the gym lot and you asked those people if they were happy. Well, if you're in the cove, maybe those people were happier because they really wanted that cove spot. So a bias is any time you did something wrong in your sampling that will favor a certain outcome. All right. Convenient samplings almost always guarantee a bias, almost always. Another type of, besides convenience, is something called a voluntary response sample. Oh, this is horrible too. So this also introduces a ton of bias. So here's what a convenient sample is. A convenient sample is when you make the mistake and ask who you want. A voluntary response sample is when people volunteer their answer. Examples of this is people calling into news stations, Facebook polls, Twitter polls. They're volunteering their answer. They weren't picked in any random way. Those are bad because this produces bias, usually in a negative, what we call direction, in a negative direction. So if I did a Facebook poll and I asked people a question about how they felt about returning to school, most of the answers that you get are strong opinions one way or the other way. You don't usually, when a voluntary response sample, get opinions of like the middle ground people, the middle 80%. Usually people that volunteer their answer is in the bottom 10 one way or the top 10 the other way in. I feel really strongly about not returning. I feel really strongly about returning. It's usually not people that are in the middle ground in these voluntary response samples. That's another bad way of sampling. So we have two so far: convenience and voluntary response. All right, so how to sample well, how to do a good sample. Good sampling has to have some kind of randomness to it. The people weren't chosen by some haphazard design. They were chosen where it was an equal chance of everybody being picked. Okay, so a simple random sample, you will see this throughout the course. A simple random sample means, and you will see SRS instead of writing this out. And you too on exams can write SRS instead of those words. Consists of people that were randomly selected. And this is super, super important. They each had an equal chance of being selected, an equal chance of being selected. So how do we do a random sample? See if I put that on my next screen. So how to do a random sample. Step one, in this class, you will always do this to get your random samples. You're going to label. So you're going to give each member of the population a number. So if you have 67 people, you're going to number them 01 to 67, or you can even number them 00 to 66. You just number the people you have. If you have 10 people, you can number them 1 to 10, or you can number them 0 to 9. You would probably want to do the 0 to 9 because then you're only reading one digit off the number table, random number table, instead of reading two digits. Then the next thing you're going to do is you're going to read consecutive tables from groups of digits from this table D. Table D is your random digit table. Okay, and then you read how many you need. All right, then your sample contains those individuals. So it's pretty easy. All you do is number your people, read how many digits you need. Now, this is not simulation. So every time you read a number, so if you read the number 37, that represents a person. It's not a simulation. You're just using the random digit table again, but it is not a simulation. You're actually picking person number 37. So you don't reuse numbers. You don't reuse numbers. All right, so these are numbers from line 130. And these are hotels. So step one was already done for you. The hotels were numbered 1 through 28. And then they used table D is your random digit table that you have. It is in your folder. If you still don't have it, you used it for simulation. We're using it again. So you're going to look at line 130. Here's line 130 right here. I just pulled it off of the random digit table. You are going to number 1 to 28. These are hotels in Hawaii. And then you're going to read two digits at a time. So here are the two digits. So 69. So you have 69, 5, 16, 48, 17. This is just the same line 130, if you look on your random digit table, and it is just broken up into two digits. Why two digits? Because I have 28 hotels, and I need to read two digits at a time. So step one, number. Step two, read two digits at a time. Okay, so 69 is not one of the hotels, so we would cross that off. 5 would be our first hotel, so Beach Castle. 16 would be our next one, Radisson. 48 is not on our list, only goes up to 28. 17 is our next one, Ramada. And then 87, Sidney Crosby's number for the Penguins, sorry, is, we're going to skip that one because we only go up to 28. 17, we already picked 17, so we skip it. 40, skip. 95, skip. 17 again, skip. And then 84, skip. It's kind of a pain, right? 53, skip. 40 skip, 64 skip, 89 skip, 87, 20 is our last one, C club. So that is a random sample. Number, get a line, start reading the digits off of the line. If you end up at the end of a line and you don't have enough, you just circle down to the next line. So you would go to line 131 and keep on going. So 130 is just your starting point. Could you pick anywhere on the random digit table? Yes. Can you pick any line to start with? Yes. But this way, we'll all kind of have the same answers. So on homework, if you have a problem number and it has a line 131 in it, that's the line number you should start with. Sometimes the homework tells you. If it doesn't, I usually will tell you in parentheses what line number to start with. All right, so other types of sampling besides random. Random sampling just takes the people you have, numbers them, and picks numbers. You can improve random sampling by using something called a stratified random sample. So the first thing that you're going to do with a stratified random sample, let me see, a stratified random sample, let me add a page. Let's say we take, here's a stratified random sample. Instead of doing everyone at UHS, which is 1,900, and asking them, would you prefer to go hybrid, virtual, or, and let's say the question is hybrid, virtual, or all in person 4 days a week. And so a random sample would pick maybe 200 out of the total of UHS. Well, as probably you know, freshmen, sophomore, juniors, and seniors all feel differently about this. All right, so if you're talking about returning to school, a stratified sample breaks people into groups first and then does a random sample of each of those groups. So if we wanted 200, 200 divided by 4 would be 50. So I would sample 50 freshmen, 50 sophomores, 50 juniors, and then 50 seniors. All right, so I would take my freshmen, number them 001 down to, I don't know, 400 or somehow many ever you have. Then I would do the same with the sophomores, 001 down to 420. How many you have those? I bet you have like about 430 freshmen. I don't know. I haven't looked at the numbers this year. I usually know them. 001 down to 430 maybe, and then let's say the senior class is the smallest, which it's not, I know. I mean, it may be, but let's say it's 410. I think it's a little more. So here's a stratified sample. These are our strata, our groups. So you first break them into groups, and then what you do is you do a separate, simple random sample. I don't know what's going on with my pen today. This is my home pen. I have a work pen too. Okay, so you would take and do a simple random sample of each of the groups. All right, these would be like 4 separate problems. So I would take and pick 50 3-digit numbers, all right, digit numbers from the random different table. Don't reuse these numbers. Pick 50 new 3-digit numbers. Pick another 50 new 3-digit numbers and another 50. Don't reuse these numbers. So once you have them stratified, you break them into, and you group them into groups. These become 4 separate problems, and they are 4 separate random samples. Now, is stratifying random? So no. So stratify is not random. A random sample says that each person has an equal chance. In this, they don't. Since since juniors have 430, they have less of a chance than seniors who only have 410. So if you're a senior, you have a 1 in 410 chance, right, of being selected approximately. Then here, juniors, you have a 1 in 430 chance of being selected. You have less of a chance of being selected. So stratifying by definition is not random. You may see that on a test. So stratifying is not random. You use random samples in each of the groups, but the groups themselves necessarily aren't the same size, so it would not be a random sample. So that's an example of stratifying. So that's that right there. Okay, other methods, cluster sampling. Well, okay, let's talk about cluster sampling. I don't really like it, but this is the difference between stratifying and cluster. And let me add a sheet here. Okay, so this is the best explanation I can give you. Let's say you have an apartment building. And in this apartment building, there's floor 1, 2, 3, 4, 5, 6, 7. Let's see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 floors in this apartment building. And on floor 1, you have apartments 1 to 20. Same thing on each floor. You have 20 apartments on each floor. Okay, 1 to 20. All right, so here's what a stratified sample is. Okay, so a stratified sample, stratified sample would be taking each floor and maybe picking 2 apartments off of each floor. Okay, 2 apartments off of each floor. All right, so maybe, and how do you get those 2 apartments? You use a random sample for each one, a separate random sample. So let's say I go to the table of random digits, I'm on floor 1, and the numbers that I get are 3 and 17. Okay, I go to floor 2 and I pick 2 more numbers between 1 and 20 off my table. And maybe those are 20 and 8. And I do third floor, pick 2 more numbers between 1 and 20, and I get 11 and 19. Do you see what I'm doing? So I would do that for each of the floors. That's stratifying. I stratified by floors, and then I'm doing a random sample of 2 apartments in each floor. That is stratifying. Okay, now here's what cluster is. I don't like cluster sampling. Okay, cluster sampling is using a random sample to pick a floor, not an apartment, but to pick a floor. Okay, so here's what a cluster would be like. I have the numbers 1 through 9 floors. So I pick a number, I pick 3 numbers 1 through 9. Maybe it's 2, 5, and 7 off my random digit table. So floor 2, floor 5, and floor 7. All the people on that floor, all the people on that floor, and all the people on that floor are asked. Okay, well, what's the problem with that? Cluster sampling sometimes has to be done in that manner, but, okay, sometimes it has to be done that way, but it's bad because you're asking all the people on that floor. So what if your question is, what's the noise level like on your floor? Well, what if on floor 2 you have an obnoxious neighbor and plays obnoxious music all the time? So everybody's going to complain about the noise level on 2. Or what if you're at the bottom floor on 2, so you hear all the noise from up above? But maybe if you're picked floor 9, people will be like, oh no, it's really quiet up here. Okay, so when you do a cluster, sometimes, not all the time, sometimes it introduces that word I was talking about, bias. Okay, so sometimes you have to be careful with cluster sampling. It introduces bias. Sometimes cluster sampling is good, sometimes it is bad. Okay, so we're going to look at an auditorium and the differences between those two and what they mean. Okay, so a simple random sample would be looking at my seats. My seats go from 1 all the way to 800. So a simple random sample is I already have people kind of numbered in these seats in this auditorium. I would go through and I would read, right, 3 digits at a time, because each person is a 3-digit number. And I would go through and I would read 3 digits until I have 80 students. So if you can't count somebody twice, right, if they're already picked. So if you picked 0 to 8, that person's picked. You're not going to pick them again. So you need 80 unique, we call it unique numbers, unique people. Okay, stratifying would be looking at them by grade. All right. And then within those sections, I would do a separate random sample. So I would pick 20 seniors, 20 of each grade. Now, once you have them in your seats, you're going to have to renumber them. So if it's 9th grade and it's 601 to 800, you're going to have to renumber them 001 to 200. You're going to have to renumber them 001 to 200. Okay, and then you're going to pick 20 from each of these to get 40. So stratifying is breaking them into the groups. They're already in their seats, renumbering, renumber. I don't know what is up with this pen. I wonder if it needs cleaned. Renumber, and then you renumber each grade 001 to 200, and then you pick new numbers for each group. It's kind of a pain. It's done faster on a computer. Okay, a cluster sample. A cluster sample would be like picking in like a whole row. So you randomly use your digit table, and let's say you pick the number 567. So maybe a row above them, that row, and the row behind them are all picked. So let's say you picked 771. So you would use that whole row, that whole cluster. Okay, do you see how it's going to be people that are all in the same grade? That's wrong. What's wrong with cluster sampling? A cluster sample is an intact group already. You randomly pick how you get that group, but it's already an intact group. So that's the difference between those. Okay, so the purpose of a sample is to give us information about a larger population. We can't look at the vaccine that we're talking about now. All these vaccine trials that are out, they're all done on samples. So there's a new vaccine that they're just looking at, the World Health Organization is looking at. It's by AstraZeneca. And it is only approved for people that are like 55 and younger, because the sample that they tested on was only of people 55 and younger. So you can only infer out to your population of your sample. So this vaccine was only tested on people 55 and younger. So when you want to infer that vaccine out to a wider population, then you can only infer it out to who your sample was done. Right now, with the COVID vaccine, there's no children getting the vaccine or even eligible, because there hasn't been any trials done on children. If the sample didn't have children in it, then you can't infer that out to the population. Okay? We call that inference, and inference is drawing conclusions. When I say the word infer, you take a conclusion from your population based on whatever your sample was. So based on what my sample was, I can only infer it out, draw a conclusion out to that population that it looks exactly like. So that is why the COVID vaccine right now is not available for children, because we haven't done trials on it. That's why the AstraZeneca vaccine was never tested on people over the age of 55. So anybody over the age of 55 is not actually eligible for it right now. They're starting more clinical trials on it. So your sample infers out to your population. And why do we rely on random sampling? It is our best and easiest way to get an equal representation of the population. Okay, it's the easiest way that we can eliminate any bias in our sampling. That's why we use random sampling. All right. Now, will we be wrong sometimes? Yes. It's called margin of error. When you do a sample, and not everybody, sometimes you're wrong. All right. Sometimes we call that a margin of error. All right. And because you're not asking everybody, you're not going to get everybody's answer. It's going to be a little wrong. All right. Larger samples give better information. The more people you ask, this is important, the more people you ask, the more accurate you are. If you do a COVID vaccine on 100 people or 1,000 people, the 1,000-person sample is going to give you better information. Okay. And then what can go wrong? These are super important. These are things that can go wrong in your sampling. Okay, one thing that can go wrong is something called undercoverage. Undercoverage is when you've left people out of the process of choosing the sample. So you go to do a sample and you, let's say you go to, I'm trying to think of an example of undercoverage that you'll understand. Let's say you call people, all right? So you're going to call people between the hours of 8 and 5. Well, who did you undercover? Anybody that works outside their house if you call home. If you only called landlines, then anybody that has a cell phone and not a landline phone, a home phone, is going to be undercovered. There was no way for those groups of people to even be asked the question. So undercoverage occurs when you set up your sample and you've kind of left people out, and there was no way for them to be asked. Okay, so non-response is when you have a hard time contacting somebody and they were chosen and you can't get in touch with them, or they refuse. So not responding. That's called not responding, non-response. All right. When you have a pattern of incorrect responses, that leads to something called response bias. You worded the question wrong. Okay, you worded the question wrong, and it leads people in to answering the question incorrectly or the way that you wanted them to do it. This is famous in politics on both sides of the aisle, both Democrats and Republicans. They will send out surveys to their base, and they will word the questions so that they answer the way that they want them to answer it. Wording of the question produces the biggest type of response bias that there is. If you do a psychological test to control for this on a psychological test, they will ask you the same question about 5 different ways to control the way that they worded it and to control this response bias. And that is section 4.1. We will work on some examples of that in class.